All right, let's talk about a core programming concept that sounds super complicated, but is actually the secret to writing really clean, flexible code. We're talking about polymorphism. We're going to break down what it is and, more importantly, why it's such a game changer.
First off, let's just get that name out of the way. Polymorphism. It sounds really academic, I know, but it's just two simple Greek words smashed together, poly, which means many, and morph, which means forms. So it literally just means many forms. That's it. See? Not so scary.
Now, if you only remember one thing from this entire explainer, please make it this phrase. One method, many behaviors. Seriously, this is the heart and soul of polymorphism, and we're going to keep coming back to it.
Okay, so what is the core idea here? Let's start with a really simple analogy to make this whole thing click.
At its heart, polymorphism is what allows us to have different objects that can all respond to the exact same command, but they each do it in their own unique way. Think about it like this. All animals can make a sound, right? But how they do it is totally different for each one. So let's say in our code we have a single command, a method called sound. When we tell a dog object to use that method, what do we get? A bark. But if we use that exact same sound command on a cat object, we get a meow. Same command, totally different behaviors depending on who you're talking to. That right there is polymorphism in a nutshell. Okay, that's a cool trick. But you might be thinking, why do we actually need this? Well, powerful ideas like this exist for a reason. They're built to solve really common and often really messy programming problems. Imagine a world without polymorphism. You'd be trapped in what I call if-else hell. Your code would look something like, if the object is a dog, then bark. Else if it's a cat, then meow. Else if it's a cow, then moo. Ugh. And every time you want to add a new animal, you have to go back and add another else if. It's clunky, and it's a nightmare to maintain. Polymorphism just gets rid of all that. It lets you write cleaner, more intuitive code that's way, way easier to scale up. All right, now that we've got the what and the why, let's dive a little deeper. Polymorphism usually comes in two main flavors, and knowing the difference is pretty important. We're going to look at compile time versus runtime polymorphism. So here are our two types. On one hand, you have compile time polymorphism, which you've probably heard of as method overloading. On the other, you have runtime polymorphism, which is known as method overriding. The biggest difference between them is when the computer decides which specific method to call, and trust me, that timing changes everything. Let's break them down. First up, compile time, or method overloading. The whole idea here is pretty straightforward. You can have several methods with the exact same name as long as they take in different kinds of information, what we call different parameters. For example, you could have an add method. If you give it two whole numbers, it knows which version of add to use. If you give it two decimal numbers, it uses a different, more precise version. And if you give it three numbers, it has a version for that too. The compiler figures all this out before the program even runs, just by looking at the data you're giving it. And now for the second type, runtime polymorphism, or method overriding. This is where things get really dynamic and, frankly, way more powerful. This is all about a child class creating its own special version of a method it got from its parent class. Let's circle back to our animal example. Say we have a general animal class, and it has a basic sound method. Then we create a more specific class, dog, that inherits from animal. That dog class can provide its own specialized version of sound. It overrides the original. So when the program is actually running and it sees a dog object, it knows, I need to use the dog's bark method, not the generic animal one. And this decision happens on the fly, while the program is running. Okay, enough theory. Where do we actually see this stuff in the real world? Turns out, polymorphism is the secret sauce behind a ton of the technology you use every single day. This is a classic example. Think about any graphics program. You can have one single command, shape.draw. But depending on whether that shape object is a circle, or a square, or a triangle, that one little command triggers completely different code to draw the right thing on the screen. It's beautiful. One command, many forms. Oh yeah, video games are built on this. A single attack command could make a warrior swing their sword, an archer shoot an arrow, or a mage cast a fireball. The game engine doesn't need to care about the specifics. It just says attack, and polymorphism handles the rest. And what about any app or website you've ever used? A click action on a button submits a form. The same click action on a link takes you to another page. A click on a checkbox just toggles it on or off. It's the same user action, a click, but polymorphism makes sure the right behavior happens depending on what you clicked. Even in something as serious as a banking system, it's crucial. A withdraw command has to act differently based on the account type. For a checking account, you just subtract money. For a savings account, you might have to check withdrawal limits first. And for a credit account, withdrawing actually increases the balance you owe. Same action, completely different rules.
So let's zoom out for a second and look at the big picture. Why is it so important to get a handle on this concept if you want to build really great software? Well, the advantages are huge. First, you write way less repetitive code. This makes your programs flexible and so much easier to scale. You can add new features without having to tear everything apart. It also opens the door to some really powerful software designs. And maybe most importantly, it helps you future-proof your code. You can add new types of objects down the road without breaking everything you've already built. Now, look, I get it. There's a bit of a learning curve. When you're just starting out, wrapping your head around these parent-child relationships can be a little tricky. But I promise you, once it clicks, the positive impact that'll have on your software is just massive.
In the end, it all just comes back to that simple, powerful idea we started with. One method, many behaviors. That's the principle that unlocks all of this flexibility and elegance in your code. And that really is the power of it all. It's a tool for building software that can adapt, grow, and change over time. So the real question I want to leave you with is this. Now that you know the secret, what could you build with it?